Thank you all for coming. This is the deep dive session for SIG Service Catalog, so hopefully that's where you all think you are. If not, you should stay here because this is by far the best talk in this time slot. I'm going to introduce myself. So my name is Jonathan Berkhahn. I'm a software engineer for IBM. I'm an open source contributor full time. This is mostly what I work on, Service Catalog itself. I'm currently a maintainer and a co-chair of the SIG itself. Previously, I worked on Cloud Foundry for a couple years, but then sort of switched over to Kubernetes, where I've been here, I think, about a year and a half now, working on Service Catalog for most of that time. So what are we going to talk about today? So yesterday was the intro session where I explained sort of what Service Catalog is and why you would want one. So that's not what this talk is about. What this talk is going to be about is a little bit more insight into the internals of how Service Catalog actually works. So we're going to start by talking about OSBAPI, which is pretty much my favorite thing to say ever. The Open Service Broker API. So what is that? Open Service Broker API is what Service Catalog is an implementation of. It's an open source API. It was originally part of Cloud Foundry that allows a cloud platform, in our case Kubernetes, to interact with a service broker, which is a web server somewhere on the network, don't care where, that offers a catalog of services. OK, now what is a service? Service can be pretty much anything, anything somebody running on the network that's accessible at a DNS address. The sort of archetypal classical example is a database. Your application running on your cloud platform needs a database to store its state. How do I get one? Do I want to write and manage one myself? No. So I want somebody to do that for me. So that's the sort of classical example of how someone would use an OSBAPI. But it can be extended to include other maybe more stranger use cases like a subscription to an API, slices of an existing long-lasting legacy database, a load balancing service where the service you provision reaches back around into your cloud platform to juggle things around, like maybe scale stuff up or down. Quite a lot's accomplishable within that framework. So yeah, the main impetus behind all of this work is that app developers shouldn't have to care how whatever their service, whether that's a database or an API subscription or whatever, they shouldn't have to care how it's managed, how it's maintained. They should be able to focus on writing their app. So the client side of this API is Service Catalog. Like I said, that's what Service Catalog itself. The server side is implemented as a broker, and many brokers are typically subscribed to a single Service Catalog on your platform end. And that can be maintained by pretty much anyone. So that broker could possibly live on your Kubernetes cluster itself. So this is just a mirror interface point for provisioning some resources within your cluster itself. It could be a broker that's physically co-located, perhaps in the same data center, that's provisioning something in the data center itself. It could be a broker that's just publicly available at some place on the internet. Maybe somebody just sells databases, and that's how they offer their services. They have some website you hook your Kubernetes cluster up to, and you say, make me a MySQL database, boom. And that broker is sort of encapsulated mostly in 3 endpoints. So I'll talk about this a little bit more later, but basically it has an endpoint for when you first register the broker of get me the catalog of all the things you offer. And then once you parse that, it has an endpoint for provision me an instance of this specific service. And then once that's done, it has bind me a binding to that specific service instance. And that's how you actually get your credentials back. But I'll go over that a little bit more in detail later. So these 8, it's really only 5 resource types are what Service Catalog is at its core. So the first, Cluster Service Broker, and we also have a namespace version called, cleverly enough, Service Broker. That's what represents the broker that's added to the cluster once at the very beginning. So that's some server running somewhere that offers various services. Using the database example over, that would be a MySQL broker. I've added a MySQL broker to my Service Catalog. Now that broker is going to offer 1 or more classes and plans, which we have represented by Cluster Service Class and the namespace variant, and then Cluster Service Plan and the namespace variant. Cluster service class is a category of services offered by that broker. So in our example, this MySQL broker, we'll say it has one class of services, MySQL databases. OK, that's cool. And then each class will have one or more plans that are associated with it. So in the case of my MySQL database class of services, that could be different sizes of database. Maybe I offer 100 megabyte, 100 gigabyte, 10 gigabyte. That would be an easy example. It could be stranger things, maybe other SLAs of latency or something like that could be encapsulated in that. It's pretty free form, so the service provider can offer generally whatever kind of plans they want. Now, past those, we have service instance and service binding. So the first three things are sort of something that's done when you register a broker, and then that state is kind of static. That's the stuff we offer. Service instances and service bindings are sort of dynamic. That's the actual make me a thing and use it resource types. So when I want a database to come into existence, I'm an app developer, I got my app, I need a database. I'm going to create a service instance, we call that provisioning. So let's say my class is MySQL databases, my plan is 100 megabyte MySQL databases. My service instance is going to be mine, Jonathan's, 100 megabyte MySQL database. When I create that service instance, we're going to go talk to the broker. It's going to create a specific database. Now, for the database example, that's fairly straightforward. But the actual action that's going on in the back end isn't really our concern. So maybe this is provisioning an actual database. Maybe it's really cutting a slice off of a pre-existing database that's already provisioned. Maybe it's blinking a light in somebody's face so a real physical person goes and connects two wires together in a data center somewhere. We don't really know or care. And then once that database, or that instance rather, is created, I need to have some way for my apps to be able to access it. And that's what bindings are for. So once I've provisioned that instance, I can bind that instance. That's what we call that action. And then it will spit back to me in a normal Kubernetes secret a set of credentials. Now, the form of those credentials is up to the individual service broker itself, but typically it's something like a port, a host name, a username, and a password to access whatever that service I just created somewhere. So I provision Jonathan's 100 megabyte MySQL database. I bind that service instance, and I get a specific set of credentials to access Jonathan's 100 megabyte MySQL database. So that's what Service Catalog actually is. We have our own API server and our own controller, blah, 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 blah. But these resource types and how to use them, that's really the crux of how it works. And then I'm going to briefly sort of demonstrate the flow of what that looks like. So like I said, the first thing that happens is I have my Kubernetes cluster. I have Service Catalog installed. I register a broker by creating one of those service broker objects. Service Catalog itself is going to reach out to the broker, hit the catalog endpoint, and be show me all the services I can buy off of this service broker. We're going to retrieve that, store it locally, keep it forever. The user then, at some later point in time, can look at that catalog and see, OK, what do I want? Provision me an instance. It's going to do this by creating a service instance object in our namespace resource types. The service catalog is going to go to the back end, going to go talk to the broker, be like, hey, provision me one of those. And it's going to, like I said, do something to create a new instance. We're then going to go and deploy our application on the Kubernetes cluster. And we're going to bind that service instance, which is going to cause Service Catalog to go talk to the broker, get those credentials, create a secret, which is then going to be attached to our app so that it can access it. So that's sort of the workflow, how it actually happens in the back end. I'm going to sort of switch gears at this point and more sort of talk about Service Catalog as a project. So we're actually sort of old, grandfathered in terms of Kubernetes extension projects. We've been around, I think, around 3.5 years now. Which means there are a lot of kind of weird corner cases in terms of the construction of Service Catalog. One of the common questions we get these days is, well, why don't you just implement yourself as CRDs? And you're like, that's an excellent question. It's because CRDs didn't exist when we started the project. We're currently in the process of evaluating them to switch to them, but for the time being, we're implemented as an API server that's aggregated into the same API namespace as the normal API server. For various sort of legacy security reasons, we didn't want the main etcd to be accessed by our exterior controller. So it's currently set up that you have to deploy your own etcd, your own dedicated etcd that acts as the host backend for our resources. It's possible to, and in fact, this is sort of the recommended way if you're actually running this in production, to just have that be the same etcd that your Kubernetes is running off of. But Kubernetes itself doesn't actually know that. Right, so the API server, on the other hand, like I said, is aggregated into the same API namespace right next to the normal API server. What does that mean? It means it's possible to use normal kubectl commands to interact with our resource types. So you're going to say kubectl create me a cluster service broker. That command's going to get passed through into the normal API server. It's going to be like, I don't know what a cluster service broker is. Oh, hey, but this API aggregated extension does. I'm just going to pass the request off to that. We get the request in our own API server, and we're off to the races. GUIDs versus names. So we deal with an external API, the OSB broker itself. This can cause some sort of weird contentions, because unlike most controllers, mainline or otherwise extension controllers in Kubernetes, we are not the sole source of truth of our world. It's possible for us to talk to a broker and it says no, or it's possible for us to deal with some pre-existing fields, names, or strings, or whatnot from the broker that Kubernetes doesn't like. So our GUIDs are not really the way we prefer to deal with things. All of our resources obviously, or sorry, our names are not the way we prefer to deal with things, our Kubernetes names. Each of our object types has a field on the spec called exterior name, which is generally just whatever the name in the OSB API of that object type is. We insert it in there as a string, and then we perform a sort of a sanitization to get the Kubernetes name. But the Kubernetes name, often that's no longer human readable once we chop it up and make it adherent to the requirements for a K8s name. So we prefer to interact with our external names on our resource types in terms of show me all the services I can buy. Here's the exterior names for our classes and plans rather than the K8s names, which can be kind of weird if you're coming from normal Kubernetes where normally just the name is that's what you deal with. This was also one of the original reasons, the original impetuses for us to create SVCat. So while you can interact with Service Catalog only using kubectl and CRUD YAML like you do normally, we have our own CLI tool to sort of ease that process, as well as interact with some of our more gnarly resource types in a more human-readable manner. Broker synchronization. So I sort of talked about this before in terms of the naming thing. There's also sort of an issue of, I don't know what you call this, resource contention. So normally, if you're a controller and you're like, I don't know, interacting with kubelets, you're like, make me 100 pods. And eventually, the kubelet's going to respond, whether that's because it's going to go make 100 pods or it's not going to make 100 pods, and then it's going to get killed, and you're going to get a new kubelet, and you're going to tell that kubelet to make 100 pods. Eventually, you will arrive at your intended destination. We have a bit of a problem in that a user could tell us, hey, delete this service instance. And we're like, OK, I'm going to go talk to the broker. I'm like, hey, broker, delete this service instance. And the broker could just be like, no, try again later. And that could just be it. So this is sort of a source of ongoing contention. We fixed some problems. There are still some looming corner cases that we don't have working yet. Particularly with delete, that's kind of the sticky one, because once a Kubernetes resource, the Kubernetes representation of this object, once its deletion timestamp has been marked, things in Kubernetes start happening that can't be rolled back. So that's kind of the sticking one. It's sort of a source of ongoing work. OK, so those are some design issues. I'm going to go ahead and get back into what the SIG has been doing in recent times. So we actually, just the week before KubeCon, cut a major feature release. We're currently still in beta. So we went from 0.1 dot whatever to 0.2.0. So those namespace resource types I was talking about earlier, those are sort of a newer feature. We just introduced those recently. They were made GA as part of 0.2.0. That was the main sort of feature contained in that release. And some of the thinking behind that was, so cluster resources, especially the things like adding a broker to the cluster, that's sort of not really a destructive operation, but it's a wide-ranging operation that has impacts for all users of the entire cluster. So if a specific user wanted to be like, hey, I have this broker, I want to be able to use it, that wasn't really something that they could do because those are often restricted to admin-only privileges to create and edit those types. But if we make a namespace version of those, then they could create a broker just in their namespace and provision and use it just themselves. So that was the reasoning behind that. I think I have some diagrams. Yeah. So this is a cluster service broker. If I register a broker with the cluster, all my users can see all the services it offers. That's obviously maybe not particularly needed if I have sensitive or, I don't know, restricted services. On the other hand, once we have made these namespaces available, I could just register it in a specific namespace, and then only the namespace users will be able to see it. So that's helpful both from a user's perspective, if they want to be like, hey, I want to bring my own broker, use it. It's also helpful from a cluster operator's perspective to allow them to restrict access to those services. CRDs. So like I said, this is sort of a hot topic. I wanted to touch on it. So like I said, we're a very old project. We existed before CRDs did, so that was why those weren't chosen when we first started. That said, we are a very good use case for CRDs. They do pretty much everything we want them to do. So we're currently in the process of transitioning to them. That's probably going to happen like very soon, probably in the next month. We've got a proof of concept working up already. Right now we're just working on massaging all of the repos and pipelines and such so that they can happen. Like I said, we're a beta release, which comes with certain guarantees of backwards compatibility. So while we are supporting the new way CRDs, and we're supporting migrations from the old way API server to CRDs, we're going to continue to support the old way API servers for at least 9 months past the release, which is sort of the source of most of our consternation. But yeah, once that's done, we can do away with our API server. We'll just at that point be maintaining a controller. We do unfortunately have to add a mutating webhook server. So there are a couple little fields in our resource types that the CRD functionality doesn't quite allow for. But this is sort of a few corner cases. But that is unfortunately going to add, well, not really add, because we're getting rid of the API server. We're adding one more binary to the system. So it's not going to be too bad. Coming soon to a service catalog near you. And then some of our other future plans. So like I said, CRDs, the synchronization issues between kube and brokers. And that's an effort not just on our part, but also a part of the OSB spec itself. So it's not a problem exclusive to our platform. That's also something that's undergoing current development in the spec level as well. User-provided services. So that's sort of a specific use case. That's something we're working on in the next release. So all the service workflows I described before, that's if I'm sort of totally in the OSB world of have a broker, provision a thing using that broker, access that service instance, so on and so forth. User-provided service is an idea from Cloud Foundry of a thing. Let's say I have some legacy service. Like I have a really old database that has all my data in it already, and I'm not moving it. Like this is my database, I'm keeping it. And I want to be able to manage access to it using the OSB workflow. You can create something called a user-provided service, which is rather than registering a broker, having classes and plans and all that, I'm just going to start at the service instance step. I'm just going to say make a service instance that's not attached to a broker, doesn't have a class or plan. It's just going to exist by itself, and hey, pass in these credentials when you create the service instance. And those credentials are going to be, excuse me. Those credentials are going to be how you access whatever your legacy database is. And then when I bind that service instance, rather than going out to a broker and doing whatever the broker's bind operation is, I'm just going to regurgitate those credentials back out. So that's a way for legacy services to be utilized within the OSB workflow. So that's what user-provided service is. That's what we're working on in the next release. Pod presets. So currently, right now, the outcome of a bind operation is you get a Kubernetes secret that's created in whatever namespace you provisioned and bound your service in. We would like to take that a step further, and rather than requiring that secret to be manually injected into your pod, to at bind time allow you to specify, I want this binding to be associated with this specific pod or this specific deployment, and so that connection will happen automatically. Just as take it one step further, make it a little bit easier for application developers to use our stuff. Docs improvements. So our docs are sort of a constantly undergoing. Sorry. Okay, docs are constantly under improvement. We're working on those all the time. And like I said, we're currently in a beta release, but we are coming up on 1.0. We've already started sort of the feature burn down list. This is sort of an optimistic estimate, but it could happen as soon as early as the end of the year. But that's not a promise. So that's what we're working on in the future. I'm going to break for questions now, but before I do, I want to mention a few links. So the first one, svcat.io, that's our main website for where all of our docs are. If you want to learn more about Service Catalog. Excuse me. The second one, our GitHub link, that's our main repository if you want to look at the code itself. Open Service Broker API, so that's the broker, that's the website for OSB itself if you want to learn more about the API itself. And if you are interested in contributing, which I hope you are, please feel free to drop in at one of our meetings. So we have weekly SIG meetings, which are at 1 p.m. PST, and that's the Zoom link right there. The first Monday of every month, we host it at 7 a.m. PST, which I think comes out to 3 p.m. here. So that's sort of an attempt to try and make it a little bit friendlier for our European contributors. There's a link to the agenda doc here. And all this is on my slides, which should be on the schedule if you want to grab them and come. OK, so that's pretty much it for me. I'll open up the floor for questions. OK, so I'm just going to repeat the question so everybody can hear it and be on the recording. His question was, could I please name the top 3 service types that are used with the OSB framework in the real world? OK, so the archetypal example I keep going over is databases. That's probably the most common one in my experience. I need a database. I don't really care. I don't want to maintain it and manage it myself. Make me a database. And that's whatever flavor database you want, MySQL, Postgres, MongoDB, non-SQL databases, whatever. So solid storage for my data. In my experience, another common type is also sort of an API subscription. So rather than go provision me a thing, it's more like give me access to an API for like payment processing. I know that's one that's on a lot of our clouds. So like my web server, my application is some sort of website that I offer, I sell something on. I have to process payments. I don't want to do that myself. Can I have access to some payment processor thing that's accessible via OSB? I don't know the common types, but I can offer a couple more that I know exist. Twilio, I know, offers their services on OSB. And that's what, web calling, right? So that's another example. Yeah. I can't really, sorry? OpenShift templates? So yeah, I work for IBM. That's mostly what I've experienced with our catalog services. I know a lot of different platforms use it for a lot of different things. But apparently that's another one. Does that satisfy your curiosity? OK. If you want, maybe find me afterwards, and I can point you in the right direction to talk to some people who maybe can answer your question a little bit more. We have down here in the front. Cross-plane? I've never heard of that now. Okay. Okay. Sorry. So I believe the question was comparing Synchronized Service Catalog with Crossplane. Unfortunately, I haven't heard of the Crossplane project, so I can't really speak to that. But again, grab me afterwards, and maybe we can chat a little bit more in depth about that. Over here? Okay, the question was, is there any plans to integrate operators with Service Catalog? Right? Okay, so operators are something I commonly get questions about why would I use Service Catalog when operators exist. So in my experience, operators are much more geared toward provisioning stuff inside your cluster on your Kubernetes itself. There are ways to make it reach outside the cluster and provision exterior infrastructure, that's true. But a lot of that requires buy-in from the infrastructure provider itself. They have to go and write an operator that's not just something to add to their Kubernetes cluster, they have to make it work with the rest of their infrastructure. So theoretically, it would be possible to replace all of the Service Catalog's functionality, but you would have to go and talk to each individual service provider and get them to write a Kubernetes operator, the cruft for that on their end. And that's somewhat unlikely considering OSB offers a platform-agnostic way to accomplish that same functionality. They can use their broker with any other platform that implements OSB. Now, it would be possible to write operators that provision Service Catalog resources. And I foresee that's a much more likely scenario. And that would be as simple as just writing an operator that manipulates our types. That would be trivial to accomplish. Yeah. Does that answer your question?
I think it's more extension of if operators deploy services, then theoretically I can use open service broker interface to get operators to provision those. So my service catalog item can be an open service interface that asks operators to provision the service.
Okay, so you're asking if I could use Service Catalog to deploy operators to provision services? To use operators to provision service. Okay, so we're sort of overloading this word services a little bit. Within Kubernetes, a service is something within the cluster itself, right? So for OSBAPI, for the brokers, that could be the case. That doesn't have to be the case. Your broker could be running somewhere else that doesn't know anything about your Kubernetes clusters, never heard of it. You could write a broker that has credentials to log back into the Kubernetes cluster on the front end and push operators. That is something that's possible. Does anybody do that right now today? I don't know. So, okay.
Stateful services. Is there a mechanism more than just create me a blank thing, but like maybe store for disaster recovery, recover for disaster recovery, that sort of thing?
Okay, so the question was, for stateful services, are there additional features that I might want, like backup, restore? That's the question? Okay. Okay, so currently, per OSB spec, no. Now, that's not to say that individual brokers can't offer those outside the spec, and in fact, many do, but it's not within the purview of Service Catalog right now today. OSB, the spec itself, is an open source project that's under active development, and that is literally something we are working on right now, is adding endpoints to the spec itself to allow a generic action of back up the service, whatever that means, restore the service, whatever that means. So not right now today, but in the very near future. Back here? I'm sorry, I can't.
Once you've bound a service, I forget what the resource type is called.
Service binding?
Yeah. How do you use that from in an application? Different services, the credentials might be, like one might have a username and password, one might have an password.
Okay, so the question is, once I've created a service binding, had that secret, how do I consume that in my application? Because the form of that might be different for different services. Okay, so you are correct that the form isn't actually entirely up to the broker. So we can't really predict what that'll look like. A lot of them are commonly username, password. Some of them might be weirder things. So that isn't really a problem that we solve right now today. Now, I'd like to make the counterpoint that we don't solve that problem, but we also didn't add that problem, because that's true even if you were provisioning like manually. I'm going to make some pods that act as my database, and I'm going to hook them up to my app yourself. You would still have to know what the credentials, how the interface is, to get it to work to begin with. So we don't really solve that problem, but we don't really add that problem. I'd like to make a point that that's another thing that's under current development at the spec level. So there are current talks, current planned features at the OSB spec level to say when a broker registers itself and it offers some service, maybe it says, it has a flag on that service that says, I am compliant with database spec 1.0. And what that guarantees is that my credentials are going to have 4 fields: username, password, port, hostname. And that'll always look like that. So that's something that's, like I said, under development, might be possible in the very near future, isn't possible today.
I guess like more concretely, say you have it, so if you provision a service through the service catalog, and you create a service binding, that fetches some credentials. But how then, like, how do you reference a field in that service binding from like a pod spec?
OK, so the question is once you create a binding, how do I actually consume that binding? OK, so the outcome of a binding is a Kubernetes secret. I mean, there's the binding object itself, but that causes the creation of a Kubernetes secret in the same namespace, and that secret has the credentials in it. So the way you actually consume it is you consume the fields of that secret with a reference in your pod spec or your deployment spec or your whatever. Any more questions? Right here. I'm sorry, could you speak up? OK, so the question is, can you group services by labels and then? I'm sorry, you're going to have to speak up.
Services with such and such labels and
OK, so your question is, can I label services perhaps with MySQL label, and then when I have services that require, say, a MySQL database, can I access those services that are labeled that generically in bulk? OK. Current answer is the same as the last 2 questions. Currently, no, that's not possible. What exactly the services that the brokers offer are sort of beyond the spec of Service Catalog itself. We just sort of query that data and display it. At the spec level, again, this is something users often ask for. So we currently, it would be the exact same feature as I'm compliant to, my credentials look like this spec. It might be I'm compliant to MySQL API 12.0 would be another label that a broker could add on a spec. So that is something that might be possible in the near future. It's not really something Service Catalog can do. It's something that OSB has to do. But maybe in the near future. Anyone else?
Companies to provide actually service broker implementations. Because service broker API is just another abstraction. But like Kubernetes becoming de facto standard, why not just provide something specific to Kubernetes? Why have this another layer?
So the question is, why offer something in a generic fashion rather than something Kubernetes specific?
About how many service broker implementations are there currently, and what motivates companies or whoever creates those to.
OK, so the question is, how many broker implementations are there in existence right now, and what motivates companies to do that instead of just making Kubernetes specific, like service offerings? Because it's generic. So this was spun out of Cloud Foundry, which is an entirely different platform from Kubernetes, which still exists, and people sell their services there. Kubernetes is the hot thing right now. And I don't know if I should say this at KubeCon, but it might not be true forever. So this is sort of an attempt to break that out so that a service provider can offer their services in a generic way that's platform agnostic. And it's not like we lose anything from it being platform agnostic. And it does allow us to sort of, like I said, all these new features that all these people have been talking about and wanting. And that's sort of incrementing it's on the OSB side. So I don't see anything that we really lose from having this platform agnostic abstraction. On the plus side, we gain all of these brokers that, like I said, this was spun out of Cloud Foundry. There's lots of companies that offer their services via broker because of Cloud Foundry. And now, okay, I'm on a Kubernetes cluster, but those brokers still exist, so I can still use those same services. That's cool. In terms of how many brokers, that's one's a little bit harder because it's not like there's any maintained central repository of all the brokers. In my experience, just with the brokers I've seen or interacted with personally, I would say it's probably hundreds of brokers running thousands of services, like offering thousands of services. I know on IBM Cloud alone, we were up to like 350 different brokers or something ludicrous like that that'll sell you anything you could possibly ever want as a service. So it doesn't seem like we're lacking from a lack of things on offer. And I would say that's partially because of the fact that it's platform agnostic. Anything else? Oh, over here again. Okay, so the question is, who are the members of the SIG itself? Now, I'd like to make the point that there are sort of two groups at work here. One is SIG Service Catalog, and that's who I'm here talking as a representative of today. The other is sort of the OSB PMC itself, which is not part of Kubernetes. I'm also a member of that, but that's like sort of where a lot of the feature work happens. The SIG itself is currently comprised of members from IBM, so that's who I work for, Red Hat, and SAP. We've previously had contributors, and still sort of do, have contributors from Google and Microsoft. Those are like the main maintainers. We've had contributions from dozens of other companies. I don't really keep track of all the people that submit pull requests. The OSB PMC itself is a little bit different composition. That's mostly, again, IBM, again, SAP, but Pivotal, who's the primary company behind Cloud Foundry, is also a major contributor in that area. So hopefully that answers your question. I think we're just about out of time. So I'm going to go ahead and cut questions short. I'll be around if you want to ask more, or if you're interested in contributing, please come up and talk to me. I have this bag of cool SIG buttons. Maybe you'll get one of them. But thank you all for coming.